Okay, so this lesson is all about effective rates. I'm going to actually do the question first and then come back to everything that says here in red because it'll explain it a little bit better once we actually have an example to work with. So this unit's going to be focusing on credit cards or charge cards, same idea. So there's going to be something called nominal rates and then your effective rates. So the ones I give you are nominal rates. So your credit card gives you your nominal rate and then there's what really happens. So let's just look at this. So number one, okay, number one is talking about 12% compounded quarterly. Great. So I'm just going to scroll this up for a second. So for all of these questions, we are going to be using the future value formula, but we're just going to modify it a little bit. So if we go over to our future value formula, it's just this one I'm using right here. I'm just going to modify it. So future value is present value bracket 1 plus r over m exponent of tm. So you've used that many times. So let's just copy that out for a sec. So you got future value is the present value bracket 1 plus r over m to the exponent of tm. So we're going to actually, so we're solving for rates here. So we're solving the effective rate, which is the real rate you're being charged. So for all of these questions, the PV we're going to use as $1 because we want to look at it as a unit rate. And so we fill out this part normal. So your rate that I gave you was 12%, so 0.12, compounded quarterly, so divided by 4. Our time is always going to be 1 that we use. Okay, so present value of $1, time of 1 year, and M is still your 4 there. So you're going to do that. But what we're going to do is add something. We're going to do a subtract 1 here at the end. Okay, so make sure you include that. So because it's not really in your formula package. So 0.12 divided by 4 plus 1 to the exponent of 4 minus 1, and I get 0.1255. Now, because I'm looking for a rate, that's the percent answer. You're going to multiply by 100. So you get 12.55%. And so this is always going to be compounded annually. So we're annualizing our rate. Okay, so let's look at what we're talking about here. We're looking at basically the credit card company would tell you, well, we're going to charge you 12% compounded quarterly. Okay, so it's 12% per year, and then it's compounded quarterly. What you're really paying is 12.55%. Um, and so what's happening is here is we're actually looking at two different things. When we're looking at credit cards, so you put a certain amount, say you put $1,000 on your credit card. Um, if we never made any payments to bring it down, then you'd be looking at this one right here, nominal rate. And then at the end of the year, or whatever, you would owe whatever amount it said with all its compounding periods, and that would be done. But that's not the case. You actually have to make monthly payments on credit cards. So because of that, we're looking at effective rates. We're looking at this one. So because we're modifying, because we're making monthly payments, um, your rate is slightly adjusted. And that's what we're solving for here. Okay, so let's look at down here. Okay, so we've got a 10% loan compounded semi-annually. Let's look at the effective rate. So effective rate, present value is always a dollar, so $1. 1 plus R over M, so 10%. 0.1. M says compound semi-annually this time, so 2. Time is always 1 year. And we said semi-annually, so times 2. And then don't forget to add the subtract 1 at the end there. Okay, so I'm going to go zero point 0.1 divided by 2 plus 1, all to the exponent of 2, and then minus 1. So I get 0.1025. Now remember, multiply by 100 so that I know the actual rate. So it's 10.25% compounded annually. So if I wasn't making any payments, then it'd be 10% on my original value. Done. Because I'm making payments probably every month, then I'm really being charged 10.25%. That's what we're talking about. So let's look at what happens here. So let's look at number 8. So we're saying let's solve for the future value. So we're going to use the 10% compounded semi-annually. Let's see what happens. So we've got on $1,200. So that's say a credit card, $1,200. Perfect. So 1 plus 10%, so 0.1 divided by 2, looking for 3 years times 2. So zero point 0.1 divided by 2 plus 1, all to the exponent of 6 times 1,200 equals, okay, so I got $1,608.11. So if I had a credit card, or in this case, it's a loan, 1,200 bucks, and I didn't make any payments towards it. So it's compounding semi-annually, so that's fine. So there's interest on interest, and so by the end of 3 years, that's how much I owe. Okay, let's look at this one. Future value. So we're using the effective rate. So 1,200 bucks, same amount. 1 plus 1.025. Now, remember, it's compounded annually, so divided by 1. We're looking for 3 years, but it's compounded annually. So when you work this all out, it's the same value. Okay, so what happens is after 3 years, I owe this amount. Yes. After 3 years, I owe this amount. Yes. The difference is this one, I would have actually had to still make payments on my loan maybe every month. So think of like a mortgage or something like that, whatever, car loan payment. So I would still be making payments every month. But then at the end of 3 years, I still owe this much. So I essentially paid more money in the long run because I made my monthly payments and then my final payment of this. And that's the difference between the two.